Hello everyone, this question is about partial fractions. Let f of x equals expressed in partial fractions. So the first step is to make sure it's proper algebraic fractions. If you look at the numerator, the highest power of x is 2, and in the denominator, if you multiply, you get x cubed. So the highest power of x is 3. We say the order is 2, the order is 3. So this is a proper algebraic fractions, so we can just do the partial fractions decomposition the right way. So the first step is to identify the forms of the partial fractions we have to use. Because of 4 plus x squared, this is the unfactorizable quadratic, so we have to use the linear numerator, ax plus b. And for this simple linear, we use the usual, just a constant in the numerator. So after you identify the forms we have to use, we multiply both sides by the denominator. So on the left they cancel out, we have only the numerator, and on the right when we multiply, so we multiply this, we cancel out, and we get only ax plus b times 1 plus x. This is what we get. And then you multiply c times this, we cancel out, which means we have c times 4 plus x squared. So the next step here is to separate, because we need the coefficients a and b and c separated. We need the 3 separated terms, so we just multiply ax times this whole thing, this is what we get, and b times this whole thing, this is what we get. So we separate the a, b, c in 3 different terms. So now we have to cleverly choose the values of x so that we can get a and b and c as fast as possible. We use the zeros. So the zeros means the values of x that make the terms go to 0. So for example, here when we use minus 1, we replace the x with minus 1, minus 1, minus 1, minus 1, minus 1. So on the left, if we replace x with minus 1, we get 5 minus 1 plus 11. On the right, when we plug in minus 1, this is 1 minus 1, which is 0. So this whole term goes to 0. Same thing here. If we plug in minus 1, the whole term goes to 0. So we have only 0 plus 0 plus, if you plug in minus 1, we get 1. 1 plus 4 is 5. So we have 5c on the right. So 5c equals, from here we get 15. So the c is 3. And we know the value of c now. We can use the other zeros. So because we have x times something, we can use x equals 0. So we replace x with 0. This is 0, this is 0. We have only 11. And on the right, when we plug in 0, if this is 0, we have 0 times anything is 0. So this is 0. And if we plug in 0 here, this is 0. We're going to get 1 times b. And if we plug in 0, this is going to be 4 times c. But we already know that the c is 3, so 3 times 4. So from here we get 12. So 11 minus 12 is minus 1. So the b is minus 1. So for the last value of x we can use, because we already have the c and the b, we can use any random number, but of course we want to use simple numbers, just use 1. Replace the x with 1, we get 5. With 1, we get 1. And we have 5 plus 1 plus 11 on the left. On the right, we plug in 1, we plug in 1, you get 1 times 2 times a. And here we plug in 1, we get 2 times b, but we already know the b is minus 1. And here we plug in 1, we get 5 times c, but we already know the c is 3. So this whole thing is 17. We have 2a. This is minus 2 plus 15, which is 13. And subtract 13 from both sides, divide by 2, we get a. So in conclusion, the a is 2, the b is minus 1, the c is 3. So this is the final answer. Alright, I'll see you again